Hello auditors, welcome to Open Zeppelin's Ethernaut Dex challenge. So this challenge, you can see that the code I've actually copied from Ethernaut, and over here let me explain what the code is. So over here we import the necessary package from the Brownie package. You can see that all these are necessary packages. So let's just dive in further. Oops, okay. So what this does is that it actually inherits a ownable contract from this particular file, and what this does is that it only sets certain functions to able to be called by the owner. So this means that this tool is useless. Why? It is because of this constructor there is no owner. But anyways, let's just move on. So what this does is that this is a simple swap function that takes an address and amount, and it checks whether token 1 and token 2 or token 2 and token 1 whether it's the tokens that is able to be swapped over here, and then afterwards it checks whether if you have enough amount to be swapped. Afterwards you actually call this get swap price. So what this get swap price does, you actually call this function. So what this function is that you actually check the price by amount. So basically, since we know that at the first place of this contract is 10 times 100 over 100. Because in first place, each user has 10 tokens as stated by Ethernaut, and then the token address have 100 each. So let's move on. So this is a very simple exploit, but I'll first explain the other functions. So, but firstly, before we're able to transfer the tokens, we have to approve them. So what this approve function is, you actually call this contract.is erc20. So what this does is you actually approve the contract that is calling it to be able to withdraw or deposit or transfer from this particular DEX contract. It's actually very simple. And then the last function is balance off, which checks the amount of ERC token in this particular contract. So let me further explain how do we exploit this function of get swap price. Over here we got this table which is nicely formulated by this block. So what we do is, firstly, let's say that I want to swap to token 2. So what you do is you get this token, multiply by this token 2, and then divide by this token 1 as stated over here. And then afterwards you will get 10 tokens, which is 20. And now the funny thing is, let's say I got 20 tokens and I want to transfer back to token 1. So what you do is 20 multiplied by 110 divided by 90, of which you'll get 24.4 with a recurring decimal. Let me just move up over here. This is the actual result here, so it's 24.44. And you can see that this is one of the problem with Solidity, as Solidity does not support floating numbers. And also you can see that there is certain flaw. Why is there a certain flaw? It's because over here, let's just say I want to swap back to token 2, 24 times 110 divided by 86. And let's just move on a little bit quicker. So 41, 30 times is it 110? 110 times divided by 80. And the funny thing is, you can see something very interesting. You can see some certain patterns here already. But it's okay, I'll move on one more time. 41 times 110 divided by 69. Now, what pattern can you see? So this pattern is actually very interesting. Over here, the direct proportion is increasing, while the inverse proportion is decreasing. So let's just check the formula here. A over B equals C. Let's say that A increase. What this means is that it's a direct proportion, C increase. And now let's say that B decrease, C will also increase because it's inversely proportional. So you can see that there's a flaw in the formula, so as the solidity floating point exploitation. But the floating point can be ignored because the real problem is the formula. So what can we do? We can actually call this attack text.so. So this is a simple contract Oops, I can't pull here. Wait, let me just pull it here. Oops. Come on, come on. Ah, nice. So what this particular attack dex does is that we firstly import the correct packages and import this particular contract, and then we'll call this dex contract so as the interfaces of the tokens, and then we'll perform a swap. But before we do that, we have to approve them. So after approving, we are able to swap the tokens, and then we were able to complete this challenge by deploying this particular Brownie script. So over here you can see that firstly we get the dex contract interface, and then deploy the attack contract, and then call the approve function, and then furthermore we can actually call the pawn function. And now why did I find it very interesting is that this particular function is very weird. If we deploy in Remix, it will work successfully, but then somehow Brownie does not I would say detect it, and whenever you call it there are some issues, but I'll just leave it there. You can actually just remove this part. And the second way to solve this particular challenge, which I would say is option 2, is because it's more Python intensive, but it's fine since we're using Brownie. And I'll explain why this is actually one of the way that I do not like it, because of the gas limit feature, where sometimes when you call this get swap price, it will not actually go through. So let me just show you here. You can see that some of the execution has reverted once, then when I call it again there are some issues, which is very frustrating. And you can see that over here gas estimation failed, but after calling it twice it somehow worked, and that's how I solved the challenge. But then I'll recommend doing this instead. So let me pause the video. Okay, you can see that we've actually completed this challenge, and you can see that after calling this deploy dex recommended Brownie Python script, we have actually successfully pawned the contract. And let me further explain, just in case you guys don't understand about this particular texting. Wait, let's remove this. Let me just add this here. Okay, so this can be removed because somehow I'm not so sure why Brownie doesn't like run this, but then when I call this over here it works, but it's fine. But anyways, if you like this tutorial, please hit the subscribe button and hit the like button. Thank you for watching and have a nice day.